Okay, so first thing I'm going to do is I'm going to have, let's see, Lizzie, the scale's on. Go ahead and set the evaporating dish onto the scale and tell us what the mass is.
26.6.
What is it?
26.6.
26.6 grams. So the mass of our empty evaporating dish is 26.6 grams. What?
So do you want the 26.61?
Perfect. 26.61 grams. That's the mass of our evaporating dish. Good. All right. Now I'm going to give you the hydrated crystal, which is a blue color, copper 2 sulfate. Okay. So there's that. Go ahead and dump that in there. Okay, that's good. All right, and what is the mass of our evaporating dish with the hydrated crystal in it? 34.54. 34.54. Good. So we have the mass of our empty dish. We have the mass of the dish with the hydrated crystal in it. So now what we're going to do is I'm going to turn my Bunsen burner on here. We're going to heat this up because what are we going to do as we heat it up? What's going to happen to, remember, those water molecules are trapped in that crystal. And when we heat it up, what's going to happen to the water molecules? They're going to evaporate. That's our hope here. All right, so we're going to put this up there. And I'm going to hold it with a set of tongs here. And I'm going to keep moving the crystals around. Okay, I'm going to move them around so that they don't cake and get stuck in like one area. And I'm going to do that with a glass stirring rod. Move it around. All right, so just gently move it around. You can see, like, it's interesting as you start to heat it up, it cakes in such a way where you can actually see that, like, it definitely has water in there. And again, you want to do this and move it around until it starts to change color. And when you're doing this and you're thinking about error, something that I always tell students to think about, you'll notice that like some of the crystal gets like stuck onto the stirring rod, see? And you can never really quite get all of that off. So when you're thinking about your sources of error, you know, you might think of some of the mass that's lost, like because it gets stuck to the stirring rod or gets stuck inside of the bowl or whatever. But again, you want to keep it moving so that it doesn't burn or get cakey, too cakey, or get stuck to the bottom. Okay, you want to come over and move it around here. Oh yeah, you guys did a good job with that. There's no burning, nothing. Most of the big chunks are all broken up. And you'll notice that that's like a smoother powder now too. No more caking. We still have some steam coming off of it, so there still might be just a little bit of water left in there. But otherwise, that looks pretty good. All right, so I'm gonna turn the heat off. And I'll give you a peek at this here. So you can see that the color there, if you can, is more of like a gray compared to, actually I'll hold it up to the container here so you can see the difference. It's like a grayish color compared to this blue. Hopefully you can make that out.
Yeah.
After we weigh it, I'll put them down on a net right next to each other so you can see them side by side. So now I'm going to place this. It's hot and that's okay. Our scale can handle it. We're going to place this whole thing on our scale and get the new mass of our, what we would call this now, our anhydrous. And when you put A at the front of a word, it means without. We're going to get it with the water molecules that have now evaporated out. Okay, so can you turn the scale on? All right, and what is the mass of our anhydrous now? And this is the container with the anhydrous crystal.
31.76.
31.76. So before we evaporated the water, the mass of the whole thing was, go ahead.
34.54.
34.54. And now after heating, 31.76. So clearly it's lighter. So that difference, remember, is the mass of our water. Now the next step would be, and I think that this, if you look at the lab handout, question number 1, I think asks for maybe the mass of just the container, or the mass of just the hydrate, so just the blue stuff. So you would take that 34.54 and subtract the mass of the container, which was the empty one that we did first. And then to get the mass of just the water, you could do the same thing. You could take the mass of the anhydrous and subtract the container, or simply you could take the difference between the container with the blue stuff, the container with the hydrate, minus the container with the anhydrous, the after we evaporated. Either way, that's going to give you the mass of the water. So when we go to try to get when we do percent composition, you take the mass of the water that evaporated and divide it by the mass of the blue stuff before we heated it. And obviously multiply by 100, and that will give you the percent composition of the water that's in the hydrate.
Okay.
See here the difference between your hydrate, nice and blue, and your anhydrous, which is like a gray color.